Hello friends, today we are going to see what do you mean by degree of freedom in context with mechanical vibration. So degree of freedom definition goes in this way: the number of kinematically independent coordinates required to completely specify the motion of the system. Now when I say coordinates, what comes in your mind? Most of the students will get an idea like it is nothing but x, y and z are the three different coordinates. So is that mean any body can have only 3 degree of freedom maximum? No, that is not the case. A body can have 6 degree freedom also. Even 8 degree freedom is also permitted. Now we will understand what do you mean by degree of freedom in detail. So for that I would suggest you to look into the diagram. The diagram goes in this way. For making you understand, I have drawn a simple spring block system with masses m1 and m2 separated by springs k1 and k2. So if I pull this mass m1 by x displacement, now let us understand what will be the displacement of mass m2. Since these two masses are connected with the help of a spring, therefore obviously the displacement of mass m1 and m2 will not be same. It will be different. It will be something else. So let us take that displacement be, let us say y. Okay. So here this x and y are not equal. Therefore these two are independent coordinates. Therefore degree of freedom of this system would be 2. Okay. For better understanding, let us take one more example of what do you mean by dependent coordinates. So for that, let us take a simple disk to which at the center of the disk I am connecting a block. Let us take block of mass m1 and disk of mass m2. These two are connected with the help of a rigid link. So if I pull this mass m1 say by x, what will be the displacement in this pulley? So let us draw the diameter of this disk. On pulling this mass m1, this disk will not be sliding, it will be rolling. So if I want to represent that rolling motion, the disk will occupy a new position somewhere like this. So where this diameter goes, this diameter will be shifted in this way. So even though this mass m1 has performed a linear displacement, but this disk is subjected to an angular displacement, let us say theta. So here we have come across two different coordinates. X is a linear coordinate and theta is the angular coordinate. But even though x and theta are two different coordinates, this theta and x are interrelated with each other. They are dependent on each other. Now let us understand what do you mean by dependent, how they are dependent. If I take the radius of the disk as r, the distance moved by the center of the disk is this much. This distance is nothing but equal to x, because this mass is indirectly connected to this center of the disk. So by how much distance I will pull this mass, the same distance will be moved by this center. And this center distance, according to geometry, it is nothing but r theta. So even though I have used two different coordinates, x and theta, linear and angular, but they are dependent to each other. So in this example, the degree of freedom of such system becomes 1, because x depends on theta. So that is a very important word in my definition. Number of kinematically independent coordinates. Here these two are not kinematically independent, they are dependent on each other. Therefore here the degree of freedom becomes 1. Let us understand further with a much complicated example. I will take a pulley over here, block. This connects with one more block, and that in turn gets connected with a pulley, and that in turn gets connected with one more block of mass. Now here if I pull this mass, let us say by x, what is going to be the motion? Let us understand with this example. I have failed to represent the mass of the pulley. This pulley has some certain mass. So let us take the mass of the pulley as M4. So if I pull this mass by X amount in the downward direction, first of all, this pulley will get rotated since it is directly connected to the pulley. So if I represent the radius of pulley in this way, as soon as I pull this mass in the downward direction, this point will be getting shifted to here and it will occupy a new position over here. So let us name it as A and the new position is A dash. So here this displacement is nothing but theta. And as soon as I pull this pulley, this block mass will also get advanced in the forward direction. So it is subjected to a displacement. Let us take that displacement as x2. And since it is connected with this block mass m1, even that will also move in the forward direction. But since these two are separated with the help of a spring, therefore displacement over here will be x3. So here now, how many coordinates I have used? I have used x as one coordinate, theta as another coordinate, x3, x2 and x3 I have used. So total how many coordinates I have used? X, theta, x2, x3. Important thing is you need to check whether these are independent or dependent on each other. So let us find this M3 is being pulled in the x direction and this pulley is also moving in the downward direction. It is going to rotate. So is there any elastic member between them? No. Therefore, this x depends on theta. So even though I have used 4 different coordinates, degree of freedom is not going to be 4. Because x and theta are dependent on each other. What is the relation? X is equal to r times theta. Let us check whether this theta and x2 are interrelated. No, they are not interrelated. There is no dependency between these two, x and theta, because there is an elastic member. Let us identify whether x2 and x3 are dependent on each other. No, it is not, because there is an elastic member. So in short, degree of freedom you can also say number of masses separated by an elastic member. So that is a shortcut way to identify degree of freedom of any mechanical vibrating system. Thank you so much for watching this video. Stay tuned with Ekeeda and subscribe to our channel.